Okay, I want to make a short video on Taylor series, maclaurin series, and show some of the types of manipulations they do. So let's start with our general Taylor series for e to the x, which we all know by heart. 1 plus x squared over 2 factorial, plus x cubed over 3 factorial, and etc. Now they ask for the Taylor series or maclaurin series for x cubed times e to the x squared. Now you could develop this from scratch by taking derivatives, etc., but as you can see it would get pretty messy. The quick way to do this is just to first substitute in x squared for x in the e to the x maclaurin series, and I'd end up with 1 plus x squared squared over 2 factorial plus x squared cubed over 3 factorial, etc. And then if I want to multiply by x cubed, each one of these terms would just be multiplied by that, and I'd end up with x cubed plus x to the 5th plus x to the 7th over 2 factorial plus x to the 9th over 3 factorial, etc. Now a lot of times they will also ask you for what's the general term for x cubed times e to the x squared. So I focus on the first term, x to the 7th over 2 factorial, where I have both the numerator and the denominator. And you can see the denominators are increasing by 1 each time. So I'm going to have an n factorial definitely in the denominator. But then look at that x to the 7th. That's odd, so I'm going to have 2n plus something in there. But if you can note that 2 times 2 plus 3 equals 7. So that works for that term. I would now check it for n equals 3, moving to the next. So I'd have 3 factorial over 2 times 3 plus 3x to the 9th. So that works. Now, often they'll ask a question like this. What is the limit as x goes to 0 of x cubed e to the x squared minus x cubed minus x to the 5th over x to the 7th? Now, on these, you've got to recognize when I had x cubed e to the x squared, all they're doing now is eliminating the first two terms and then dividing everything by x to the 7th, which will leave me with 1 over 2 factorial plus x squared over 3 factorial plus x to the 4th over 4 factorial, etc. But if I want to take the limit of that as x goes to 0, you can quickly see it's just going to be the first term, 1/2. Now another type of question they ask is, for x cubed e to the x squared maclaurin series, sorry for me writing Taylor, what is the 9th derivative of that at 0? Well, let's look at x cubed e to the x squared again. Now, some of you will see this immediately, but for those of you who don't, when I take x cubed and then take the first derivative, I get 3x squared, second 6x, third 6, and then the 4th and 5th and 6th derivatives are all going to be 0. You can see with the x to the 5th term, the same thing would happen. X to the 7th, you would eventually get to 0 too, since I'm taking the 9th derivative. But with x to the 9th, my first derivative is 9x to the 8th. My next one's 9 times 8, x to the 7th. And you'll see that when I come all the way down to the 9th derivative, I'm going to end up with 9 factorial times 1. So the answer to questions like this are, in this case, it would just be 9 factorial. Look at the x to the 11th term. After I take 9 derivatives of that, I'm still going to have an x squared term. For the next term, x to the 13th, I'd be left with x to the 4th. And all those terms, when evaluated at 0, will go to 0. So, limit questions like this, you should be looking up, they're lopping off the first two terms and then dividing by 7. And the only term that's going to last when x goes to 0 is that first one. when they ask for things like this, like the ninth derivative evaluated at 0, it's going to be that x to the ninth term that's going to end up being a constant after you take the 9 derivatives, and the only one that's going to last. All right, have a good day.